Good evening, all. Welcome to today's live discussion session for the NPTEL course Soil Mechanics, Geotechnical Engineering. I am Reshma R, Research Scholar from Civil Engineering Department, IIT Madras. So, welcome to today's live discussion session on Soil Mechanics and Geotechnical Engineering. We'll wait for 2 more minutes and then we'll start the session. I shall share my screen now. Hope the screen is visible for you. Okay, we'll start the session. We'll move on to the first question. So, here is the first question for today's session. The changes that take place during the process of consolidation of saturated clay include option A, an increase in pore water pressure and a decrease in effective pressure. Option B, an increase in pore water pressure and an increase in effective pressure. Option C, a decrease in pore water pressure and an increase in effective pressure. Option D, a decrease in pore water pressure and a decrease in effective pressure. So, what is the change that will take place during the process of consolidation of saturated clay? What is the effect of consolidation on pore water pressure and effective pressure? Which of them will be increasing and which of them will be decreasing during the process of consolidation? You can put the answers in the chat box, or you can unmute yourself and say the answer. Which of the option is correct? What will happen to pore water pressure and effective pressure during the process of consolidation of saturated clay? All right. So the correct answer is option C. So during the process of consolidation, pore water will get expelled out of the soil pores. So pore water pressure decreases and hence effective stress will increase. I hope that is clear to you. During the process of consolidation, the pore water is being expelled and hence the pore water pressure decreases, which in turn causes the increase of effective stress. Moving on to the next question. The stress strain behavior of soils as shown in the curve 2 in the figure corresponds to option A, loose sand and over consolidated clay. Option B, loose sand and normally consolidated clay. Option C, dense sand and over consolidated clay. Sorry, option C, dense sand and normally consolidated clay, and option D, dense sand and over consolidated clay. So the curve 2 represents which type of soil? Loose sand, dense sand, normally consolidated clay, or over consolidated clay? Which type of soil does the curve 2 represent? The given graph is a stress strain graph. Which one is the correct option? Okay, so correct answer is option B. So we know these two graphs. That is, this is the standard graph plotting deviator stress and axial strain. Deviator stress on y-axis and axial strain on x-axis. There we can see the lower curve, that is the curve 2 in our problem, represents loose sand and normally consolidated clay. The given curve represents loose sand and normally consolidated clay. Curve 1 represents dense sand and over consolidated clay. Alright, so here we have the third question. The void ratio pressure diagram of a soil sample is shown in figure below. The coefficient of compressibility is, we are given a void ratio pressure diagram. We are asked to determine coefficient of compressibility. Option A 0.35, option B 0.2, option C 0.15 and option D 0.014. It's easy to solve. It's a direct substitution in the equation for coefficient of compressibility connecting void ratio and pressure. So which is the correct answer? Okay, let's see which is the correct option. Answer is option B. So we are given that void ratio initially it's zero point 0.6 and finally it is zero point 0.7. That is, in this curve we are given two void ratios and corresponding pressure values. So E1, E2 and P1, P2 they have given. So E1 is zero point 0.6, E2 zero point 0.7, P1 155 and P2 162. This is the given value and coefficient of compressibility is given by the equation delta E by delta P. That is, the ratio of change in void ratio to change in pressure gives the coefficient of compressibility. Coefficient of compressibility is calculated by determining the ratio of change in void ratio to the change in pressure. So, substituting the given values, we get coefficient of compressibility as 0.014 meter square per kilonewton. Hope that is clear to you. Okay. Here we have the fourth question for today. In a 15-meter thick soil stratum with its initial void ratio zero point 0.5, the void ratio decreases to 0.35 when the effective pressure on the stratum increases by 1.25 kilogram per centimeter square. The coefficient of volume change of the soil is, so we are given 15-meter thick soil stratum which had an initial void ratio of zero point 0.5 and a final void ratio of 0.35. And this void ratio reduction happened when the effective stress was increased by 1.25 kilogram per centimeter square. We are asked to determine the coefficient of volume change of the soil. Option A 0.08, option B 0.34, option C 0.034, option D 0.67. Okay, so the correct answer is option A, sorry, 0.08. So we are given thickness of soil stratum, initial void ratio, final void ratio, and change in effective pressure. The equation for coefficient of volume change of the soil is given by coefficient of volume change mv is equal to delta E by delta sigma into 1 plus E naught. Substituting the given values, we have coefficient of volume change of the soil as zero point 0.5 minus 0.35 divided by 1.25 into 1 plus zero point 0.5, which gives you a value zero point 0.08 centimeter square per kilogram. So this question is also direct substitution into the equation of coefficient of volume change of the soil, that is mv is equal to delta E by delta sigma into 1 plus E naught. Please raise your hands if you have any doubts. So assuming that everything is clear till now, I'm moving on to the next question. That's our fifth question for today. In a 15-meter thick soil stratum, that is the same soil sample as the previous question, with the same value of initial void ratio, that is zero point 0.5, and the final void ratio 0.35. When the effective pressure on the stratum increases by 1.25 kilogram per centimeter square, here we are asked to find the consolidation settlement of the stratum. So in the previous question, we had calculated the coefficient of volume change for the same soil stratum. In this question, we are asked to determine the consolidation settlement of the stratum. Option A 5, option B 50, option C 100, option D 150. Which is the correct option? We are given the thickness of the soil stratum, initial void ratio, final void ratio, change in effective pressure, and we know the coefficient of volume change from the previous question. So what is the consolidation settlement of the stratum? Okay, I have got one answer as option C. Let's see. Um, so actually the answer is option B, that is 150. Let's check how. So we are given that the thickness of the soil stratum is 15, initial void ratio zero point 0.5, final void ratio 0.35, and change in effective pressure as 1.25. The equation for consolidation settlement of the stratum is SC is equal to MV H naught delta sigma. MV is the coefficient of volume change, which we had calculated in the previous question. H naught is the thickness of soil stratum, and delta sigma is the change in effective pressure. Substituting all the values we have, it is 150 centimeters. We have 150 centimeters as the consolidation settlement of the stratum. Hope that is clear. Okay, I think we have lost the friend who have answered it as C. I think it's clear to him also. Okay, we'll move on to the next question. In a consolidation test, void ratio decreased from 0.75 to zero point 0.5 when the pressure was increased from 50 to 100. The compression index is, so a consolidation test was conducted and the void ratio was found to decrease from 0.75 to zero point 0.5 when the pressure increased from 50 to 100. What is the value of compression index? Option A zero point 0.3, option B 0.83, option C 0.95, option D 1.2. which is the correct option. Okay, so we'll check how to solve this problem. We are given the initial void ratio 0.75, final void ratio zero point 0.5, initial pressure 50, and final pressure 100. The compression index is given by the equation Cc is equal to delta E by log to the base 10 sigma 2 by sigma 1, or P2 by P1, where sigma or P represents the pressure and E the void ratio. Substituting the values, we have compression index Cc is equal to 0.75 minus zero point 0.5 divided by log to the base 10 100 by 100 by 50. So the value we get it as 0.83. The compression index we get it as 0.83. Okay. Next question, question number 7. The natural void ratio of a 4.8 meter thick saturated clay strata is 0.97. The void ratio of the clay at the end of the consolidation is expected to be 0.64. The total consolidation settlement of the clay strata is option A 80, option B 90, option C 70, and option D 50. We are given that the natural void ratio is 4.8 meter thick. Natural void ratio of the 4.8 meter thick clay layer is 0.97 and the final void ratio is 0.64. We are asked to determine the total consolidation settlement of the clay strata in centimeter. Okay, the correct answer is option A. So we are given initial void ratio as well as final void ratio, also the thickness of the soil strata. So the total consolidation settlement of the clay strata can be estimated by using the relation between delta H by H and delta E by 1 plus E naught. Rearranging the equation for delta H, or the total consolidation settlement of the clay strata, we have delta H is equal to delta E by 1 plus E naught into H. So after substituting the given values, we'll get it as 0.97 minus 0.64 into 4.8 divided by 1 plus 0.97, which gives you 0.8041 meters, but we are asked to determine the value in centimeters, so converting we get 80 centimeters approximately. Okay, moving on to the next question. Question number 8. Due to the construction of a new structure, the average vertical pressure at the center of a 2.5 meter thick clay layer increases from 100 kilopascal to 200 kilopascal. A laboratory consolidation test was performed on a 20 mm thick undisturbed sample of the clay. Under applied stresses of 100 kilopascal and 200 kilopascal, the void ratio of the sample were found to be zero point 0.9 and 0.786 respectively. The probable primary consolidation settlement of the structure is option A 50, option B 100, option C 150, option D 250. So here the vertical pressure is increasing from 100 to 200 kilopascal and the void ratio is decreasing from zero point 0.9 to 0.786. We are asked to determine the probable primary consolidation settlement for the structure. The correct option is option C. Sorry. So we are given initial void ratio and final void ratio, thickness of the soil stratum and change in applied stress. So the equation for primary consolidation settlement, as we have seen in the earlier questions, SC is equal to mv into h naught into delta sigma. So here mv is equal to delta E by delta sigma into 1 plus E naught, which gives the coefficient of volume change as we have seen in the earlier problems. H naught is directly given in the question and delta sigma is also mentioned. So first we need to calculate the coefficient of volume change mv. Substituting the values, we have coefficient of volume change mv is equal to zero point 0.9 minus 0.786 by 100 into 1 plus zero point 0.9, which will give a value equal to 0.006 meter square per kilonewton. Now substituting all the values in the primary consolidation settlement equation, SC as 0.006 into 2.5 into 100, which gives you 150 mm. That is option C. Moving on to last question for today's session. A 3-meter thick layer of saturated clay lies in between two permeable layers. The clay has a liquid limit of 45% and initial void ratio of 1.25. The initial effective overburden pressure at the middle of the clay layer is 500 kilopascal and is likely to increase to 1000 kilopascal due to the construction of a new building. The probable primary consolidation settlement of the building and the final void ratio of the clay are respectively. So, here in this question, the thickness of the saturated clay layer that we are considering is 3 meter. It has a liquid limit of 45% and initial void ratio of 1.25. The initial and final effective overburden pressure is 500 and 1000 kilopascal respectively. We are asked to determine the probable primary consolidation settlement and the final void ratio. Option A 95.4 and 0.955. Option B 126.4 and 1.155. Option C 155.8 and 0.857. Option D 200.5 and 0.754. So we'll see how to solve this problem. The correct answer is option B, that is 126.4 mm primary consolidation settlement and 1.155 final void ratio. We'll see how to solve this. Here given the thickness of clay layer as 3 meter, liquid limit of clay layer as 45 percentage, initial void ratio 1.25, initial effective overburden pressure as 500 kilopascal, expected final overburden pressure as 1000 kilopascal. So we have an equation connecting the primary consolidation settlement and initial and final effective overburden pressure. Also the initial void ratio is given. SC is equal to CC by 1 plus E naught into H into log 10 of P0 plus delta P by P0. Here all the values except CC, compression index, is known. We have CC, the equation 0.009 into WL minus 10 when liquid limit is known. Substituting the value of liquid limit, we'll get the value of CC as 0.009 into 45 minus 10, which is 0.315. Substituting all the values in the equation for primary consolidation settlement of the stratum, we have SC is equal to 0.315 by 1 plus 1.25 into 3 into log to the base 10 of 500 plus 1000 minus 500 by 500, which gives you a value 0.1264 meters or 126.4 mm. They're also asked to determine the value of final void ratio. So as we saw earlier, we have the relation delta E by 1 plus E naught is equal to delta H by H, or delta E is equal to delta H by H into 1 plus E naught. Substituting the values, we have delta E is equal to 0.1264 by 3 into 1.25, sorry, into 1 plus 1.25, which gives you a value of 0.0948. With this, we come to an end of today's live discussion session. So if you have any doubts, please ask. If not, let's conclude for today and we'll meet again during the next session. Okay, so we'll stop here.